Era già acceso. Sono il presidente di questa commissione che prevede inizialmente la discussione della tesi di laurea dei 4 laureandi della laurea magistrale, la prima della quale la vedete collegata perché si trova in India. Poi avremo 3 presentazioni in presenza degli altri 3 candidati. Dopodiché la commissione si ritirerà in un'altra aula per deliberare e decidere le valutazioni. Se la commissione è disciplinata e brava, nel giro di mezz'oretta dovremmo fare tutto, e dopodiché ritorneremo qua per la proclamazione sia dei laureati magistrali che dei laureati triennali, che ci raggiungeranno in un secondo momento. Okay? Poi la seduta si concluderà con alcune valutazioni del Presidente della Commissione. Quindi direi che ho dato tutte le indicazioni, giusto? Devo dire qualcos'altro? No? Ok, quindi possiamo procedere. Vado in inglese appunto perché la laureanda è indiana. Indira, can you hear me?
Yes, sir.
Okay. When you are ready, we can start. You can start with the presentation.
Okay, I will start now, sir.
Okay.
Okay. Respected dignitaries and my dear friends, a warm good morning to one and all. Today I am going to present my thesis topic, Radiation Analysis of 5G, the 5th generation of mobile networks. First of all, I would like to thank my advisor, Professor Luca Vincerti, and my co-tutor, Mr. Stefano Lenzini, for their immense support and motivation during the completion of this thesis work. Abstract. This thesis deals with the analysis of 5G networks. As the next generation infrastructure, 5G networks aim to significantly increase the speed and capacity of 3G and 4G mobile communications. Here we discuss the underlying technologies, particularly from the perspective of evolution of millimeter wave technology. So, 5G is the 5th generation of cellular networks. It's up to 100 times faster than 4G. It is the emergence of new radio for mobile cellular communication networks. The spectrum of 5G services not only covers the bands below 6 GHz, but also it includes the bands that are currently used for 4G LTE networks. It also extends to the much higher frequency bands that are not previously considered for the mobile communication. There are certain key features for the 5G networks that it have faster connectivity speed, ultra-low latency, and greater bandwidth. In order to support the need of increased traffic capacity in the network, the millimeter wave frequency spectrum is being used for the first time for the mobile communication technology. Evolution of 5G. So, the evolution of generations of mobile communication networks has begun from first generation in the year of 1980s. At that time, we were using analog transmission, and that is implemented for voice communication. That type of voice communication was not that much clear. So, in the next generation, that is 2G, the digital voice communication came into existence with greater voice capacity. And later, the 3G mobile communication came into existence in the year 2000. That time, people were able to use mobile internet for browsing and everything, and smartphones also came into existence. During 2010, the 4G, that is the 4th generation of networks, came into existence with video and broadband data. That time, people are able to communicate each other through video conferencing and everything with much more data rates and much higher bandwidth. And during 2020, the 5G massive broadband connection came into existence with ultra low latency and network slicing. The 5G is going to be implemented soon in many countries. So why we are using 5G? The three major reasons for you implementing 5G are the increasing demand, crowding, and lack of bandwidth. So in this increasing demand means people are using mobile communication these days for picture communication, audio calls, online gaming, and everything. So many people are using that. So there is an increasing demand for the accessing of mobile networks. This will create a kind of crowding in the mobile network, and sometimes there will occur delay and lack of bandwidth. So, in order to overcome these kind of issues with much more higher bandwidth and much more faster data rate, we are trying to implement 5G networks. The application of 5G. 5G applications are mapped into three different classes of user cases that are enhanced mobile broadband, massive machine type communication, ultra reliable low latency communication. These are the three user cases in the case of 5G application. In the enhanced mobile broadband, the speed is up to 10 to 20 times faster than 4G. By using massive machine type communication, we can connect up to 1 million devices per square kilometer. And with the help of ultra reliable low latency communication, it guarantees latencies that is below 10 milliseconds. So, in the application side, 5G can be implemented in various sectors like consumer market, industrial communication, automotive industry, smart agriculture, smart grid, smart healthcare, etc. So, in the working side of 5G technologies, various key enabling technologies are being used. So, those technologies are beamforming, massive MIMO, visible light communication, device-centric architecture, millimeter wave, small cells, terahertz waves, full duplex. These are the key enabling technologies of 5G. And my focus is over the millimeter wave. So let us see the millimeter wave frequency spectrum. According to the 3GPP standard, there are uh, range, two frequency range designation is given, FR1 and FR2. In the FR1, the corresponding frequency range is sub-6 gigahertz frequency, and in the FR2, the frequency range is in millimeter wave range, that is 24 to 100 gigahertz. We can see in the 5G spectrum that is divided into sub-6 gigahertz and millimeter wave frequency. Here, the wavelength of electromagnetic wave is in the millimeter wave range. The bands from 24 gigahertz to 100 gigahertz are expected to use for the 5G cellular network. So, why we are using wave technology, the millimeter wave technology? It is because the major reasons are because of more bandwidth. It is the frequency can be reused efficiently. The practical antenna array on chip is feasible, propagation low, and it is sensitivity to blockage. So, according to Shannon's equation, high data rates requires higher bandwidth. So, in the case of higher bandwidth, it is rare in the case of lower frequencies. So, if we are trying to implement higher frequencies, definitely there will occur high free space path loss. So, at that time, a line of sight is required. So, in order to prevent these path loss, countermeasure to overcome the path loss are put directivity into the radiation using beamforming and active antenna system. In the case of 5G millimeter waves, we are using phase array antennas for in order to overcome these kind of path loss issues. The advantages and disadvantages of using millimeter wave technology. The major advantages are the wide bandwidth in the 5G networks enables high speed, high capacity, and low latency. Since the wavelength is short and antenna size is small, it makes easy for an antenna array to beamform and produce many narrow beams. Major advantages of millimeter wave for 5G networks are the higher data rate and spatial multiplexing. The disadvantages are the millimeter wave bands. It suffers from high spatial attenuation that limits the transmission distances. Its transmission is very straight and therefore it requires line of sight. It have higher penetration loss through the glass and walls, which make the penetration of waves a little bit difficult. So these are the disadvantages in the side of using millimeter waves in the 5G technology. The millimeter wave phased array antenna technology. So this type of antenna is having higher directivity and it transmits radio waves over a long distance. So a phased array antenna is an antenna that controls the direction of radiation of radio waves by superimposing signals from different phases. So in the operation side, when two waves of same phase are in the same direction, they are superimposed and resulting waveform consists of larger amplitudes. On the other hand, when two waves are in opposite phase and superimposed, they cancel each other, leaving out no energy. So this is the operation of millimeter wave phased array antenna. The side of radiation analysis of 5G networks. The next. So the radiation can be classified into two: non-ionizing radiation and ionizing radiation. In the ionizing radiation, middle to higher range frequency are used. It includes ultraviolet rays, X-rays, and gamma rays. In the ionizing radiation, in the non-ionizing radiation, it has lower frequencies and bigger wavelengths. In the future analysis, now the 5G is trying to implement everywhere. Definitely for the future, the 6th generation network is coming to exist, and various use cases of 6th generation networks are the self-driving vehicles, global connectivity, extended reality, that is augmented reality, virtual reality, robotic and industrial automation, enhanced e-sport, short-range D2D communication, smart railways. These all are the expected future use cases in the case of 6th generation mobile network. So let me conclude my fifth topic. 5G is going to be a new revolution in the wireless system market. Many countries have begun to roll out 5G, including new mobile terminals that are comparable to millimeter wave technologies. The implementation of new 5G mobile standards and the use of millimeter wave spectrum is expected to be revolutionary. The millimeter wave band being made available for mobile networks, and it will provide increased performance, better coverage, increased bandwidth, and higher data rates, as well as extending into higher frequency millimeter wave bands. The future advancements in the wireless communication will have a profound impact on the world around us. Thank you so much for the attention. Thank you.
Okay, thank you, Asokan. Are there questions? Okay, there are any questions, so we can skip to the next student. So thank you again, and see you later, roughly about 10:30 or 11. However, I will send to you an email before.
Okay, sir.
Okay, if you want to stay connected, you can. Otherwise,
okay.
you can do other things. Okay.
Okay.
See you later.
See you later.
Ok, bene. Bene, ora possiamo passare al prossimo candidato che è in presenza ed è Giovanni Braglia. Quindi qua devo fare qualcosa nel mio PC, Moreno? Ok, allora io mi sposto dall'altra parte.
Good morning, everyone. I'm Giovanni Baraglia. That's the presentation that I prepared for my thesis, which is called An Embedded System for Non-Intrusive Load Monitoring Using Machine Learning. So first of all, I wanted to start explaining what is non-intrusive load monitoring, which is basically a technique to perform the power management of a certain system and enable us not just to know how much we are consuming in terms of energy, but also enable us to know who are the devices that are consuming that amount of energy. Let's suppose, for example, that we want to have some information about this kitchen. Here, as we can see, there's a fridge, there's an electric boiler, and there's a microwave. So what we might think is to apply a sensor for every one of those devices. And then we can think about developing a mobile application which is able to collect all the data that are coming from all different devices. So what we propose with non-intrusive load monitoring is to get rid of all those sensors and then use just one single unit that alone is able to tell us that there is a fridge, there is an electric boiler, and there is a microwave oven consuming a certain amount of power. So this can be done if we think about having a device that must be connected to the main power delivery bus. And this device should be able to detect every appliance when it turns on, and then to recognize them through some classification algorithms. So the strategy proposed in this thesis to perform this kind of task is presented here in this scheme. First of all, I started with two public available datasets where voltage and current waveforms of domestic appliances were recorded. Then those waveforms were used to extrapolate some features and save them into a dataset that was used then to train some classifiers that in this case were logistic regression, support vector machine, k-enable classifier, random forest. So those basically are some machine learning models that are able to recognize the device that we are trying to measure based on the information that we send to them. So once the best classifier was chosen after an evaluation process, we can save that classifier into an embedded system where I also implemented a detection algorithm, a disaggregation one, and a feature extraction process. So we now try to explain this upper branch. First of all, the detection algorithm, which is the one that enables us to detect every turn-on events. This algorithm works simply analyzing the aggregated power signals. It computes its envelope, and from the envelope, it calculates iteratively its variance in a way that if we set a threshold to the variance, we know that an event occurs. So the event might be a turn-on or a turn-off event, then we should select the turn-on event in a way that starting from that event, we can analyze a certain window of the signal. But before analyze that window, we need to disaggregate the signal. And that means that we need to clean the interval that we want to measure from other signal components. So from other devices components. So suppose that we are now trying to measure this signal here. What we need to do is to clean this interval from other possible devices components that turn on before the one that we want to analyze. This can be simply done if we take this interval, we take the interval that comes before, we align those correctly, and if we think that we are on a linear scenario, we can simply subtract one from the other in order to obtain this blue signal here, which is now ready for the next process, which is feature extractions. So those features are the information that are required for the classifier to recognize the appliance that we are trying to use. measure. And all those algorithms that I presented before, and also the classifier, were also implemented on an embedded system, which is this one, which is NVIDIA Jackson TX1 developer kit, which is basically a PC board with some machine learning libraries already installed. And also, it's a very powerful system because it is featured with a GPU that might be used for some future works that I will explain better later. So the first result obtained in terms of accuracy for the two data sets, so the first one here were the result for the cool data set, and those were the result obtained for the lead data set. Those accuracy here were obtained for the test data set. So that means that the classifier were trained, were evaluated, and then after this training process, I send some new data to the classifier, and almost in the 90% of the cases, all the classifier were able to recognize the device that we were trying to measure. Moreover, I tried also to record the execution times from the embedded system that I was using, and that's because in this way we had some more data in order to evaluate the system that we were using. So as you can see, this classifier here, which is the random forest, turned out to be the more complicated one, but it also the one with the best accuracies that we can obtain. And all those results were also, let's say, recorded into an article that was presented this month at the 15th Brazilian Congress on Computational Intelligence. But then one of the questions that I had were how much we can trust the proposed algorithm. And that's because all the public available data set that I was using had some waveforms that were recorded into some, let's say, special cases. So what happens when we are trying to measure those waveforms in a real scenario? And then I decided to make my own waveform data set. I decided to measure 5 different appliances, and then I decided to apply to them the same strategy that I applied for the first data set. So I built a filter data set, and then I sent a new waveform after a model evaluation process for the classifier through this algorithm chain, which of course have a detector algorithm and disaggregation one block for the feature calculation, and then the classifier model that was saved before. So please pay attention that those were the different classes that I was trying to recognize, but those 2 classes are basically the same device on different working stage, as well as those last one. And that is important because when I was trying to to further validate my algorithm, the first accuracies that I obtained in terms of training accuracy were actually good because they were always over 90%. And that happened also for the test accuracy. But then what happens when I try to send new data and I try to perform over than 100 measurements, the number of errors was too high, and that made my algorithm unreliable. So what I tried to do was to investigate more on what was going on. And if you remember here, I said that there were one device which was split in 2 different classes because of its different working state. So what happens is that actually in this case, the classifier were thinking about this device as one single device. So the classifier was not able to cluster the features into two different groups. And that can be acceptable because we want to know that this is a PC. We are not it's not strictly important to know if this PC is in a certain working stage or in another. And it happens also that I found some error for this folder, which actually had some really different waveforms when we are talking about different working state. But this happens because I was recording some waveforms with a very large time window. So every time I was analyzing a certain working state, some spures of the other working state appeared. So the classifier was able to recognize those two different working states, but since I was supposing that just one working state was recorded, I thought that there were some errors. So with more investigation and increasing manually the amount of information in the lab feature dataset, I was able to obtain those results. So in terms of the logistic regression, I found that the performance decreased. But in the case of the other classifiers, the performance actually increased a lot. And moreover, for the final validation test, I performed over than 500 measurements. And as you can see, in the case of super vector machine and random forest classifier, the number of errors even decreased with respect to the first validation test, where I performed less number of measurements. So we can conclude then that the proposed algorithm works. It has a robust solution to perform non-intrusive load monitoring. We decided that a random forest classifier turned out to be the most suitable one for this kind of strategy. And also the methodology was also run on a system that might be implemented for some future works, where we might think about performing non-intrusive load monitoring for more complicated systems. So those might be a system with multiple rooms, where we might think about applying some digital signal processor for the detection, the disaggregation, and the feature extrapolation block. And then we could use the PC board that I work with to gather all the data from the DSP, and then to perform that machine learning part that might be performed also in parallel if you are able to use the GPU. And then this board might be used to establish some communication protocol with some mobile devices in order that the user is always aware about its energy consumption and aware about which are the devices that are consuming a certain amount of power. So here I conclude my presentation. Thanks for the attention.
Thank you. Our questions?
Thank you, Luca. Thank you for the presentation. I have two questions for you.
Yes.
First one, when you talk about the linearity of the load, as you know, several power supply are switching power supply that are practically non-linear. For example, the power supply of your PC is for sure not linear.
Yes.
Could you comment that and say the effect on your approach? Second question, could you tell us more about the training of your network?
Yes.
And when you add, for example, a new load, what happens for the training?
Yes.
Thank you.
So first of all, we always had in the back of our mind that those are non-linear devices. And that approach for disaggregation that we use, it's actually, we are trying to simplify a lot the scenario, which is, of course, nonlinear. So this introduces some error. As a matter of fact, when we are trying to perform this kind of classification, I was using a technique which is called supervised learning. And that means that the classifier during the training data set needs, before to analyze a feature data set, and then based on those feature data set, they adjust some parameters in order to make other decisions. So since we wanted to, first of all, to clean the signal, because when we are talking about, sorry. Because in this case, it is clear that here, this is a current signal. So what happens is that if we switch on in sequence multiple devices, the current requirement add one from the other, because of course we need more current to power all the different devices. So it's clear that we need to disaggregate in some kind of way this signal, because otherwise we would end up analyzing a signal whose amplitude is greater than the one which is actually the current needs that the device had. So we take into account that this is approach that is not correct. But even analyzing the previous literature, there were other group that was using this kind of technique. And to be sincere, I always use this algorithm without thinking about other ways of doing that. But actually, this can introduce some error from the point of view of the signal that we are analyzing. But if we are able to provide the correct amount of information during the training process, which is the one where the classifier start to know the nature of the data that they need to recognize, so we can get rid of that bias, because the content of information that we send to the classifier is correct. And also because when we are analyzing during the training process the classifier, there are some techniques that enable us to increase the performances of the classifier. One of that is a technique that reduces the amount of information that the classifier needs to recognize the device. This technique is called sequential backward selection, and enable us to spot all those features that are actually reducing the performances of the classifier. So if there are some error here, we can get rid of those errors during the training process, because we let our classifier know who are the most important information that they need to recognize the devices.
Okay, thank you. Are there any other questions here? Okay, Andrea, can you hear me?
Yes, I can hear you.
Okay, you have any question?
No, I guess we had a long discussion yesterday during the Giovanni's defense here in Brazil. So from my side, everything is okay. Yeah. Thanks.
Okay, vai, vai. Okay, so thank you very much.
Thank you.
Ok, adesso possiamo... Hai ragione. Acceso. Adesso possiamo passare alla prossima candidata, che è Valentina Di Pinto, che presenta una tesi dal titolo A Device for Investigating the IPRGC Contribution to Papillary Light Reflect with Silent Substitution Techniques.
Okay. Hi, good morning to everyone. My name is Valentina Di Pinto, and today I'm going to present you my thesis work project that I have carried out at the Optolab laboratory of the university. And it is related to a device for investigating the IPRGC contribution to pupillary light reflex with silent substitution technique. Here, now the outline of the presentation. So I will briefly explain to you the motivations and the objectives of my thesis, together with some anatomical hints about the eye and what are the IPRGC photoreceptors. Then I will provide you an explanation about the silent substitution technique and about also our developed instrument. Then I will briefly discuss about the pupils area monitoring results, and I will conclude with some future improvements. So the IPRGC study is nowadays a hot research topic because less is known about these photoreceptors that constitute the retina, and IPRGC stands for intrinsically photosensitive retinal ganglion cells. Indeed, they are studied since relatively few decades, and moreover, there is a lack in the instrumentation that addresses their contribution to the PLR, that is a pupillary light reflex. And their study could reveal additional information about their contribute to human visual system and possible eyes diseases, such as glaucoma or retinitis pigmentosa or many other ones. We wanted to develop a suitable instrument for IPRGC's simulation and moreover characterize the components, validate the instrument basing on suitable measurements, and then acquire some measurements for the pupils area variation analysis. And let's briefly discuss about the eye, that is one of the most important sensory organs that conveys the light, the collected light into nerve pulses. It is mainly constituted, so the parts of interest for us are the pupil and in the front of the eye and the retina in the back of the eye, constituted by photoreceptors that are photosensitive, so sensitive to light. We can have three main types of photoreceptors. In particular, at the beginning, the PLR was mainly attributed, or better, only attributed to cones and rods, where cones are photoreceptors mediating the color vision, and so being sensitive to colors by expressing the photopsin protein. And instead, rods are responsible for the monochromatic vision, thus being simulated in dark luminosity conditions by expressing rhodopsin protein. IPRGCs, instead, as I have just said, are studied since relatively few decades in the PLR contribution field. In fact, their main their main function is to regulate the circadian rhythm, but and also to directly act as a contact between the cones and rods, so the photoreceptors, and the optical nerve, so their nervous system. In fact, they convey light stimuli they received from them to the nervous system. On the other hand, they are also light sensitive, and this is due to melanopsin, that is a protein they express. They are very difficult to be stimulated because they constitute only a very small percentage of the overall number of photoreceptors in the retina, only the 5%. Moreover, they are less light sensitive than cones and rods, and they respond much slowly than them. Here there are the spectral sensitivity curves of each photoreceptor, and as you can see, they show a partially overlapping Gaussian distribution. This partial overlap is the consequence of their large non-specificity in the light response, so they are color blind, and they weight the input light by only means of their spectral sensitivity curve. And this concept can be exploited by the silent substitution technique by simply keeping constant the stimulation of rods and cones in order to evaluate the one instead of IPRGCs that instead varies. So we keep constant the stimulation of rods by controlling the environmental illumination, and the one of cones by delivering to the subject metamers that are colors, as you can see here in the slide, that are perceived by the human eye as completely equal, so constituted by the same RGB coordinates, but constituted also by different spectral distribution. And by changing the spectral distribution, we can change the melanopsin stimulation level. We have tried to exploit this technique by our instrument, whose, let's say, block diagram is set up here, where we have used a diffusing surface here, as you can see, a dichroic that it transmits towards the diffusing surface the visible, and it reflects a wavelength from 750 nanometers towards an infrared filter with 700 nanometers cutoff and an infrared camera. We have, moreover, employed as a light source here some LEDs, in particular 8 RGB LEDs and 8 yellow LEDs circularly disposed around a 1-inch converging lens. And moreover, we have used 4 circularly disposed infrared LEDs with 850 nanometers peak wavelength in order to properly illuminate the eye for a proper acquisition from the camera. Here another view of the instrument. So as you can see, it is quite compact, and here there is the 3D view, and here instead the view with the volunteer. And regarding the diffusing surface I have shown to you before, it has been a big issue for this thesis because it should show Lambertian properties, thus it should equally reflect in all the directions an impinging light beam. And after trying, as I have reported here in the figure, and after trying different solutions, different possibilities, we have employed as material barium sulfate mixed with water and transparent paint in order to cover the diffuser that I have reported here. And at the end, we have obtained this reflectance trend that in the visible ranges from the 95% down to the 90%, thus being suitable for the application. Here we can see a small part of the entire LabVIEW interface that I have developed in order to here control the system, here select the LED's intensity in order to find, for example, a desired color. And with LED intensity, I mean the duty cycle of the PWM signals that control the LEDs, and here instead there is the sub-VI concerning the metamers selection. So you can, for example, select the RGB coordinates you want and then get the corresponding metamers, or you can directly insert the LED intensities that you want. And okay, we have carried out 2 test versions on 8 volunteers in order to, let's say, evaluate the physiological response of the eye, and moreover to check if there were dependencies in the color delivery order. And each test lasts 8 minutes, where in practice we alternated a pose where we delivered a fixed color to an alternation between 2 different metamers that are always the same, but with a different frequency, with 4 different frequencies. And in the 2 versions of the test we have delivered, so in the first, 1 alternation, 1 Hertz, 0.5, 0.2, and 0.1 Hertz as a metamers alternation frequencies. And instead, in the second version, we have reversed the order. Thus, 0.1, 0.2, 0.5, and 1 Hertz. Here in this table, I have reported the delivered metamer's LEDs intensities, so for the red, green, blue, and yellow. And as you can see, the M1 and M2 show this intensity as 2, 0, 0, 46, and 2608. Okay, and the AVG is simply the average between the two intensities that we delivered to the subject during the pose, so during all these parts of the test. All the colors correspond to the same RGB coordinates that are 255, 136, and 0, and correspond to the same luminosity that is equal to 21, and they are orange. Due to the approximations in the color computation algorithm and also in the spectral computation algorithm we have developed in LabVIEW, the two colors resulted to have a slightly different luminosity, and therefore we had inevitably stimulated also the cones and not only the IPRGCs. So let's go on. Here, I have reported to you the different spectra of the metamer 1 and of the metamer 2. And as you can see, they are different. So here you can appreciate on the left the yellow and the red peaks for the first metamer, and on the right the green, yellow, and red peaks. And as you can see, there is the comparison between the real and the computed spectrum, where the real has been computed by the spectrometer, has been acquired by the spectrometer, and the computed instead has been computed by performing the convolution between all the LEDs spectra, and after they have been weighted to their output current computed by the power meter. As you can see, the mismatch is acceptable. Here it is the worst part in the green one, and so that's why we probably also stimulated also the cones. Before evaluating the acquired data, we elaborated them by firstly computing the pupil's area through a Python script and plotting its variation over time. Then we have removed all the frames where the subject had the eyes closed, and removed the DC, resampled everything and detrended, and then we have low-pass filtered all the data at the same frequency that was 2 Hertz. We have computed the spectrum of the baseline noise and also of the useful signal, and then subtracted them in order to finally evaluate the peak spectral response. Here I provide to you only the first test version results because for time reasons, and the second test version results are, let's say, similar. So here you can see the 1 Hertz, 0.5, 0.2, and 0.1, so from the left to the right and from the upper part to the bottom one. And as you can see, the spectral response, the peak, increases more and more. So we have a peak inevitably due to the, as I have just said, the cones stimulation. But on the other hand, we have the proof that the IPRGCs responded, have been stimulated because the peak increased more and more by decreasing the frequency. And as I have just told you, the IPRGCs are much slower than the cones. Here another comparison between all the metamers, and as you can see from the right up to the left, the spectral response, the peak increases more and more as the frequency decreases. So in conclusion, we have developed an instrument, a correctly working compact instrument prototype for the IPRGC stimulation. So we have concluded that IPRGCs were successfully stimulated, even though we also and inevitably stimulated the cones due, for example, to non-perfect Lambertian properties of the surface, also to non-ideal color synthesis and spectral computation algorithm, and non-perfectly linear yellow LED response. And in my opinion, I think that as future improvements, the same test could be replicated with, for example, other metamer pairs with lower Michelson contrast, for the IPRGC stimulation, or more peak wavelength LEDs or different peak wavelength LEDs could be employed. Moreover, in order to improve the results, we could also improve the luminosity resolution and study the paint mixture with other materials and other technologies. So thank you for your attention.
Okay, thank you. There are questions? Nothing? I have just a curiosity about the two spectrum, the measured and the simulated one, maybe the slide 12, something like that.
Yes.
Okay, you say that the agreement is very good, I agree with you. But my question is, have you an idea why there are different peaks in the two spectra?
We have that the two spectra are different because they are, let's say, different colors, even though they have the same RGB coordinates. So in the first metamer, we delivered different values in the LED intensities, so in the PWM duty cycles controlling each LED. So, for example, in the first metamer, the green LED was off, and therefore we, for example, do not we do not have any peak in the green since it is off. Instead, in the metamer 2, for example, there is the green, the yellow, and the red color. So these three LEDs are on, and therefore we have the green peak, for example. And
Okay. Other questions? No, ok. Quindi possiamo passare all'ultimo candidato. È acceso una volta. Goldoni Daniele, che presenta una tesi dal titolo Design Optimization and Characterization of Optical pH Sensor for Extracorporeal Circulation.
Okay, good morning to everyone. I am Daniele Goldoni, and I'm going to present you my thesis work with the title Design Optimization and Characterization of an Optical pH Sensor for Extracorporeal Circulation. This work is the result of my internship experience at Mario Veronesi Technopole in Mirandola, and also in collaboration with a company of the biomedical district that is called Medica. Now, extracorporeal circulation in general is a medical treatment that involves the blood flowing outside the patient's body with different purpose, for example, hemodialyzing or oncological treatment. The blood pH is very important to be measured in this kind of medical treatment. Generally, the blood pH is bounded between 7.36 and 7.44. And variation from this narrow range may result in critical problems for the patients. Thus, for this reason, during extracorporeal circulation treatment, the blood pH is analyzed, usually nowadays with the use of blood gas analyzers. This kind of analysis requires the sampling of the blood from the tubing system, and thus it is quite complex and also time expensive for the operator. For this reason, recently it is proposed a measurement system that is based on the fluorescent analysis of a sensing element in contact with the blood flowing in the tubing system that allows a real-time and non-invasive and also safe and cost-effective measurement of the blood pH during extracorporeal circulation. Of course, also with accurate and stable performance, and in particular, the estimation error benchmark for this kind of treatment is that the pH must be, the estimation error must be lower than 0.04 pH. The measurement principle of this sensor is, as stated before, the fluorescent analysis of a sensing element, whose main component is called HPTS, that is a pH-sensitive fluorophore, and in the center picture is reported the absorbance spectrum of the sensing element. And in fact, as you can see, it varies as a function of the pH. Thus, by analyzing two different spectral regions, we can calculate the R value, that is basically the ratio of the normalized signal, signal emission of the fluorescent emission signal when the sensing element is excited at 465 and 405 nanometer. Then the R value is linearly related to the pH, and alpha and beta are the linear calibration coefficients that are experimentally obtained. Now, very briefly, the measurement algorithm that I briefly explained before. First, the sensing element is excited at 405 nanometer, and the fluorescent emissions is acquired at 520 nanometer. Then basically the same is done for the 465 nanometer. Here in this slide, it is reported the complete flowchart of the algorithm that is implemented in LabVIEW. And as you can see, from the complete flowchart, also the temperature is measured during the process for two main reasons. The first one is that, as we will see later, the sensor exhibits non-negligible temperature dependence, and also, generally speaking, the blood pH varies as a function of the temperature. Thus, it is important to have a temperature reference signal. Now, let's start talking about the work for this thesis. First, it was based on the analysis of a database of previously acquired PBS tests, and also I performed a new PBS test with the ACC system implemented at MS2 laboratory. Then these tests have been elaborated in order to add information about the noise and the long-term stability performance of the sensor, also the calibration coefficients variability, and as stated before, the temperature dependence. Also, tests on blood have been performed in collaboration with the medical laboratories. And one of the most important results of these tests is the implementation of a temperature correction model that allows to measure the blood pH also in presence of large temperature variation in real time. Then finally, we investigate an hardware modification of the system in order to improve the sensitivity by changing the 405 nanometer source with another wavelength. Here in this slide, it is reported the ACC system setup implemented at medical laboratories that correspond to the schematically reported circuit on the left. Basically, the roller pump makes the blood flow in the tubing system, and the sensing element, as you can see, that it is directly inserted in the tubing system. The heat exchanger allows to control the temperature, and the blood pH can be varied with the use of the gas exchanger. Here, once again, it is reported the implementation of the PBS test at MS2 laboratory at the Technopole. PBS is a buffer that is commonly used in biomedical research, and the implementation of this system is similar to the one described in blood in order to have, of course, as similar as possible conditions. Now, about the results of these tests. Part of my work was based, especially at the beginning, on the analysis of a trade-off that exists between the long-term stability and the signal-to-noise ratio that are both related to the LED power and the number of samples that are used for diverging at each sampling interval. Based on the test that we have done, we choose the parameters that are reported in the slides that allows to obtain, as a result, an acceptable noise level and also an acceptable variation, an acceptable long-term variation of the R values. As you can see, lower than 1% after 10 hours. These parameters are the ones that are used for all the following results. About long-term stability, just a few additional words. It is very important, the long-term stability performance of the sensor, because generally speaking, extracorporeal circulation treatment may last for several hours. And in this slide, it is reported an example of a PBS test that lasts about 24 hours. And as you can see, the error is always lower than 0.04 pH, and on average, it is quite low, 0.018 pH. Here in this slide, I reported the consideration about calibration coefficients variability, alpha and beta, on 12 different disposable cuvettes. As you can see from the central picture, they display a quite high variability, and this is mainly due to the fact that the deposition method of the sensing element on the cuvette is still at a prototypal level. Thus, in PBS, during the PBS test, we obtained this kind of variability. The temperature dependence results, as you can see from the central picture, the estimated pH and the temperature signal are clearly correlated. The temperature reference is acquired with an NTC sensor in line within the tubing system. And on average, we defined a temperature sensitivity that is about 0.02 pH for each degree. Now let's start talking about the blood test results. 4 tests have been performed in total, as you can see, with the 3 different disposable cuvettes, with 2 different optical heads, and within 2 days of acquisitions. In all the cases, the pH can be effectively measured, and as you can see, with a 25-second sampling interval, it is obtained that the estimation of the pH is almost instantaneous with respect to the reference. As stated before, also a temperature correction model has been proposed and implemented. On the right part of the slide, it is reported an example of one of the 4 tests that have been done. And as you can see, the pH can be precisely measured also in presence of large temperature variation. The model that we have implemented is linear and take into account also the temperature in the calculation of the pH. In the slide are reported the parameters experimentally obtained from these 4 tests on blood. And as you can see, on average, the error is very low, with a maximum estimation error that exceeds the 0.04 pH value only for a very low value of pH, as you can see from the central picture, for values lower than 6.9. Now, finally, as stated before, based on the results of the blood test, we observed that the fluorescent emission of the sensing element, when it is excited at 405 nanometer, exhibits a very low sensitivity to pH variation. Thus, we investigate the possibility of improve the overall sensitivity of the measurement system by changing the 405 nanometer source with another source with a wavelength about 378 nanometer. In this slide, I reported the results in PBS with this modification. As you can see from the left part of the slide, the normalized emission sensitivity to pH variations increased with respect to 405 nanometer, while, as reported in the right part of the slide, the temperature sensitivity remained almost comparable. The test that we have done on blood about this modification not allow, unfortunately, have a robust conclusion about these sensitivity improvements. So of course, further analysis must be done. So to conclude my presentation, I told you about the analysis of the trade-off and the choice of the optimal parameter that, as we have seen, allowed to obtain an acceptable noise level and a long-term stability that is demonstrated up to 24 hours in PBS and 6 hours on blood. Also, as described before, in a blood environment, the pH can be precisely measured. Also, in presence in presence of temperature variations with the implemented temperature correction model, and of course, also the temperature dependence has been defined in PBS. Then, finally, we investigate the possibility of a pH sensitivity improvement with the modification of 1 out of 2 source with 378 nanometer LED. And in PBS, we demonstrate this improvement, but on blood, we need, of course, further analysis. So, thank you for the attention.
Thank you. Are there questions? No.
Thank you for the presentation. Just a question. When you say that you optimize the parameter, what kind of algorithms did you use to run this optimization?
It was basically there was no algorithm employed for the optimization. It was an optimization based on the test that we have done with several conditions of LED powers and the parameter that are shown in the slide. And the complexity of the system not allowed to have implemented a robust algorithm for this kind of optimization. Thus, we simply, based on the tests that we have done with different conditions, we define this parameter that are reported in order to obtain both an acceptable noise level, but simultaneously a long-term stability that was acceptable too. Yes, exactly, yes.
Ok, other questions? Ok, allora direi che non ci sono altre domande, quindi ci possiamo fermare qui. Abbiamo concluso le presentazioni, quindi come vi dicevo adesso la Commissione si ritira in altra aula per deliberare e ci vediamo tra circa mezz'oretta. Bene, allora concludiamo questa seduta con la proclamazione dei laureandi, prima laureandi triennali e poi quelli magistrali, e quindi partiamo da Baesi William. Baesi William, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 100 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Ballestrazzi Luca. La commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 97 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Carletti Mel. Carletti Mel, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea col punteggio di 88 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Garuti Lucia. Garuti Lucia, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 99 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria. Complimenti. Ipocoanna Federico. Ipocoanna Federico, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 103 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Memeo Giacomo. Memeo Giacomo, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 106 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Micolitti Massimo. Micolitti Massimo, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea col punteggio di 107 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria. Minichelli Francesco. Minichelli Francesco, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 103 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Montanari Giulio. Montanari Giulio, la commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 101 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Palmieri Davide. Palmieri Davide, la Commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea col punteggio di 100 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Turci Giulia. Turci Giulia, la Commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea con il punteggio di 102 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Vita Leonardo. È la triste storia di chi ha il cognome che inizia per la V. Io mi chiamo Vincetti. Okay. Vita Leonardo, la Commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato la sua prova finale ha approvato il suo esame di laurea col punteggio di 96 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in ingegneria elettronica. Complimenti. Bene, adesso passiamo alla proclamazione dei laureati magistrali. La prima studentessa è una studentessa indiana che è in collegamento con noi, quindi inizierò a parlare in inglese, farò la proclamazione prima in inglese, anzi la farò in inglese, dopodiché inizieremo con i 3 studenti qua in presenza in italiano. Okay, Indira, are you ready? 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 Okay. Indira, are you ready? 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 Ok, partiamo da Braglia Giovanni. La proclamazione ufficiale in italiano. Braglia Giovanni, la Commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato il suo lavoro di tesi ha approvato il suo esame di laurea con il punteggio di 110 su 110. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore in Electronics Engineering. Cosa ho detto? Dottore senza magistrato. Perché ho scritto male. Dipinto Valentina. Dipinto Valentina, la Commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato il suo lavoro di tesi ha approvato il suo esame di laurea con il punteggio di 110 su 110 e lode. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore magistrale in Electronics Engineering. Complimenti. Goldoni Daniele. Goldoni Daniele, la Commissione ha preso atto del curriculum dei suoi studi e dopo aver valutato il suo lavoro di tesi ha approvato il suo esame di laurea con il punteggio di 110 su 110 e lode. Pertanto, per i poteri conferiti dalla legge al rettore di questa università e a me delegati, la dichiaro e proclamo dottore magistrale in Electronics Engineering. Complimenti. Scusate, adesso ho rifiato un attimo con la mascherina. Allora, come avevo anticipato all'inizio, è prassi e usanza concludere questa cerimonia con alcune parole del Presidente della Commissione, che non sia nemmeno togato, scusate.
Quindi non vale la... Dobbiamo rifare tutto, non vale la laurea. Non vi siete laureati. Ripartiamo. Sembri un pittore.
Allora, scusate, eravamo talmente presi con i vari collegamenti e quant'altro che mi sono scordato un po' della forma. Dicevo, si conclude con un breve discorso. Non posso che cominciare facendo i complimenti e congratulandomi con gli studenti sia della triennale che della magistrale per l'importante obiettivo raggiunto, consapevole che poi è stato raggiunto in una situazione di particolare difficoltà. Ieri riflettevo sul fatto che oggi probabilmente è la prima volta che incontro tutti questi studenti di persona. Io ho un insegnamento sia alla triennale, 2 alla magistrale, ma non ho mai avuto occasione prima di incontrare questi studenti, quindi siamo ben consapevoli della difficoltà che hanno incontrato gli studenti, diciamo così, dei sacrifici che hanno fatto, tenuto conto che questa situazione o questa pandemia colpiva principalmente altre categorie, altre fasce d'età, quindi diciamo lo sforzo, i sacrifici che hanno fatto questi studenti ha un valore doppio, e spero poi che nel futuro le generazioni come la mia e quelle più anziane, quelle anche un po' più giovani, riconoscano il sacrificio enorme che è stato fatto da questa generazione. Ci sono 3 punti che vorrei mettere in evidenza, che emergono da questa particolare sessione di laurea. Il primo è che per la prima volta, non è un obiettivo raggiunto, ma penso che sia comunque un segnale positivo, tra i laureati magistrali abbiamo 2 uomini e 2 donne. Il numero di studentesse che si iscrivono in ingegneria elettronica è storicamente abbastanza basso, però penso che possa essere anche un segnale incoraggiante il fatto che almeno per una volta abbiamo raggiunto da questo punto di vista la parità di genere. Tenuto conto anche del fatto che le statistiche dicono che i laureati in ingegneria elettronica dal punto di vista del salario sono quelli che hanno differenza tra uomini e donne, ma la differenza è molto ridotta rispetto ad altre categorie professionali. Gli altri due aspetti importanti che emergono sono il fatto che, come avete visto, abbiamo anche proclamato una studentessa straniera, indiana, che a causa della pandemia poi è dovuta tornare in India e ha concluso il suo percorso da casa. Questo grazie al fatto che, come avete visto, come saprete, il nostro corso di laurea da un certo numero di anni è erogato interamente in lingua inglese. Il secondo aspetto è che oggi per la prima volta si laurea uno studente che conseguisce, o che ha conseguito, perché la prima parte l'ha già fatta ieri, ha conseguito un doppio titolo riconosciuto sia in Italia che in Brasile grazie ad un accordo che il nostro Ateneo ha stipulato con l'Ateneo brasiliano. Per queste due ultime ragioni, rompendo un po' la prassi che vede il discorso fatto dal Presidente della Commissione, vorrei cedere la parola al Professor Pavan, che è stato Presidente del corso di studio in quegli anni in cui con una certa lungimiranza ha proposto sia il passaggio del corso di studio in lingua inglese che poi l'attivazione di questo doppio titolo. Paolo.
Grazie. Grazie, mi sento un po' come il paparino di questo evento. Sono molto contento e molto soddisfatto per questa giornata che riassume veramente il lavoro di tanti anni che abbiamo fatto con tutti i colleghi per riuscire a portare questo corso di laurea ad essere un corso di laurea internazionale e ad avere legami anche con altre università. In particolare, a parte il passaggio all'inglese, il modificare anche, c'è stata tutta un'evoluzione in questi anni che ha permesso al corso di aggiornarsi, ammodernarsi e cercare anche di essere più competitivo nel mercato. Gli elettronici sono pochi per definizione, se volete passare la voce non se ne trovano in giro, ce ne devono essere di più, noi però abbiamo sempre meno studenti che altri corsi di laurea, quindi i nostri studenti sono merce rare, i nostri laureati, le aziende sono disperate e cercano di trovarli, quindi mandate i vostri amici a fare ingegneria elettronica perché ce n'è bisogno e hanno un radioso futuro davanti, peraltro. Dal punto di vista invece del doppio titolo con il Brasile, devo dire che è stata un'esperienza molto interessante e particolare, nata qualche anno fa e che ha prodotto già diversi risultati importanti. Per noi il primo studente e unico finora è Giovanni Braglia, che probabilmente con il suo carattere ha sopportato anche uno stress test non trascurabile nell'andare in Brasile, nel momento in cui partiva anche il lockdown in quella nazione, con tutte le difficoltà che questo ha portato, ma non si è mai perso d'animo e ha anzi fatto un lavoro eccellente sia lì che qui quando è tornato. Quindi sicuramente gli riconosciamo, vogliamo anche noi riconoscere a lui un grande merito e ringraziarlo per quello che ha fatto. Dall'altra parte, da questo punto abbiamo ricevuto una studentessa brasiliana 2 anni fa, poco prima del lockdown, che è venuta qui, ha fatto la sua parte e quindi abbiamo già una studentessa brasiliana che ha preso il doppio titolo con noi e uno studente italiano che ha preso un doppio titolo con il Brasile. E questo è stato lo stimolo per ulteriori azioni. Abbiamo anche nei percorsi di dottorato che alcuni di voi affronteranno la possibilità di fare il doppio titolo sempre con l'Università Tecnologica Federale del Paraná a Curitiba e negli altri punti del campus. Quindi ci stiamo muovendo per rendere i nostri studenti non solo europei ma internazionali e i risultati sono notevoli. Ieri pomeriggio, durante la cerimonia che ha visto la difesa della tesi, una vera difesa perché ha dovuto rispondere per 1 ora e mezza a domande infuocate dei vari professori che c'erano nella commissione di laurea brasiliana, hanno fatto i complimenti ai nostri studenti, al nostro sistema di preparazione e di educazione perché notano che c'è una capacità notevole di rispondere e di adattarsi anche a condizioni molto particolari. Quindi volevamo informarvi anche, insomma, cerchiamo di fare tutti questi processi di rinnovamento del nostro corso di laurea, ma li possiamo fare solo perché abbiamo degli studenti molto bravi. Grazie ancora.
Bene, grazie Paolo per il tuo intervento. Non mi resta che concludere salutandovi e facendo un grosso in bocca al lupo a voi, ai vostri familiari, ai vostri cari, ai vostri amici, sperando insomma che il peggio sia passato e il meglio sia di fronte a noi. Grazie.